Hello everyone, welcome back to my channel. I am Sujan, studying in 6M ISC Sri Venkateshwara College of Engineering. Today we're gonna discuss about one interesting subject, software testing. In that, and a very interesting topic, variation on mutation analysis. Let us see what are all there in the introduction part. Mutation analysis is a software testing technique used to evaluate the quality of the test cases. Okay, first of all, I will tell you what is software testing. When some code or some software is developed, so before is published into or it is used, it will be tested. So how long, what and all the things the developers have did, are they are correct, are they are working properly for all the cases. These and all the things we are going to do in the software testing. Okay, in that mutation analysis is a main part. So okay, let us discuss what is mutation analysis. Mutation analysis is a software testing technique used to evaluate the quality of the test case. It involves creating small changes in the source code known as mutant and then running the test cases against this mutant to determine if they can be detected. Okay, when something fault is happened, then this fault is a cause for an error. Okay, so those fault can be overcome or changed in the source code, and that is known as a mutant, and those cases are detected and run successfully here. It is in the mutation. Okay, next, variants on mutation analysis. The mutation analysis process describes in the preceding sections, which kills mutants based on the outputs proceed by the execution of the test cases, is known as a SANG mutation. It can generate a number of mutant quadratic in the size of the program. Each mutant must be compiled and execute with each test case, and it is killed. Okay, in above lines it's specifying that the mutant is analyzed, it will be described in some preceding sections that kills the mutant. Okay, and it will be having a quadratic mutant size in the program. Okay, and to remove or kill that mutation, each mutant will be compiled and executed separately to kill each of them. Okay, at a time we cannot take the time and space required for compiling all mutant and for executing all test cases for each mutant may be impractical. Okay, it's saying that the time and space that is required to kill and compile and execute and kill those mutants are not according to the practical, or it cannot be say how long or how average time to kill that mutants. Okay, the computational effort required for mutation analysis can be described the number of mutant generated and the number of test case to be executed. Weak mutation analysis discrete the number of test cases to be executed by killing mutants when they produce intermediate state, rather than waiting for a difference in final result or observable program behavior. With weak mutation, a single program can be seeded with a many fault. A meta mutant, okay, you know the meta meaning. Meta is nothing but a definition having another definition. Okay, then in the same way, mutant having another mutant in it. Meta mutant program is divided into segments containing original and muted source code with a mechanism to select with the segment to execute. Two copies of the meta mutants are executed in tandem, one with only original program code selected and the other with a set of live mutant selected. Okay, now execution is passed after each segment to compare the program state of the two variation. If the state is equivalent, execution resume with the next segment of the original and the muted code. If the state differ, then the mutant marked as a deal and execution of the original or muted code is restarted with a new selection of the mutant weak. Mutant testing does not decrease the number of program mutants that must be considered. Okay, here it's saying that the each segment passed to the program with the two versions. If state is equivalent, the execution resumes with the next segment. Okay, if the state are the equivalent to each other, then the execution of the mutants will move to the next segment of the original muted code. If states differ, then the mutant is marked as a deal and execution of the original and muted code is restarted with a new section of the mutant. Weak mutation does not decrease the number of program mutant that must be considered. but it does decrease the number of test execution and complication compilation. This perform benefit as an accuracy which mutation analyze may kill a mutant even in the changed intermediate state would not have an effect on the final output or observable behavior of the program. Like the structural test adequacy criteria, mutation analysis can be used either no judge the toughness of a test vote or to guide selection of a additional test case. If one of is designing test case to kill a particular mutant, then it may be important to allow a complete of a set of mutant generated by a set of mutation operation. If on the other hand the goal is statistical estimate of the extent to which a test suite distinguish program with the seeded faults from the original program, then only a much smaller statistic sample of the mint is required. Aside from its limitation to assess rather than the creation of least suits, the main mutation of the statistical mutation analysis is the partial coverage, meaningful only the extent of the generated mutants are a valid statistical mode of the occurrence frequencies of the actual fault. To avoid the reliance of this impossible assumption, the target coverable should be 100% of the sample. The statistical sampling may be keep the sample small enough to permit careful examine of a equivalent mutant. Okay, in this we are seeing that how the two version of mutants will work and how it will go to another segment. If when it differs, how it will move to the next segment by stopping that, and what is a weak mutation testing, and what is a test coverage about it, and all we see here. Next is a challenges in a mutation analysis. One of the challenge in the mutation analysis is a large number of mutants that can be generated, which can make it impractical to test on them. Okay, one of the challenges are analysis large number of mutants can be generated which make it to impractical to test on them. Okay, the large number of mutants will make an impractical to test on them. Okay, another challenge is the determining which mutants are equivalent, meaning that they do not change the behavior of the program and therefore do not need to be tested. Okay, finally the conclusion part. Mutation analysis and its variations are important tools for the evaluating the quality of the software testing and ensuring the celebrity of software application. By understanding the challenges of the techniques, software developers and testers improve their process and deliver their products to the user. Okay, the main your use of the software testing or by using anything fault failure error is how the program gonna work, the software gonna work, whether if need to work for 10 cases, the one who testing the software will test for it for 20 cases, and it work for all those 20 cases, then the software will be work everywhere in the they use. If one of them can go fault, then there will be a fault in the software that have been developed. Okay, this is about the variation of the mutant analysis. Thank you everyone. Please do like, share, subscribe, and thank you one and all.